Welcome back, my friends. Today we are working on asymptotes.
I can't wait to learn calculus.
Awesome. Well, let's start off. What is an asymptote? An asymptote is a point that will never be crossed. So on a graph, the graph might go like this. It may go like this. Either way, it will never cross this line or this line, no matter how far the graph goes. So today, we're going to be working on how to figure out which asymptote and what the line is. So this one, we'll start off first. This is a horizontal asymptote. Now, horizontal asymptotes, they come in three packages. First, you've got it if it has the same degree, such as 2x over 3x. The degree is just the exponent on the variable. So if they have the same degree, you just do the ratio of the coefficients or the numbers in front of the x's. So in this case, we will have a horizontal asymptote at y equals 2/3. For the next one, I'm actually going to use the problem that we'll use for the vertical asymptotes. So, if f of x is equal to x squared minus 1 over 2x plus 4, find the asymptotes. So the second choice is going to be if the degree on the top is bigger than the degree on the bottom. Now on the AP Calculus exam, they might explain this as the numerator and the denominator. But for the case of this video, we're just going to go with top and bottom. So in this case, the top degree, x squared, is greater than the bottom degree of 2x. In this case, when the top is greater than the bottom, there is no asymptote. For our third choice, where we've got the bottom, or the denominator, is greater than the top, or the numerator, such as x squared over x cubed, your horizontal asymptote will be 0. So at y equals 0, you would have a horizontal asymptote. Now, I'm going to teach you about vertical asymptotes. For vertical asymptotes, there's a different way to figure them out. So, you usually have to work out the problem. So we're just going to use the same problem. First, what you can do is you can try to simplify the denominator. Because for the case of vertical asymptotes, you're going to be trying to figure out what makes the denominator, or bottom, equal to 0. So first, I'm just going to break it out from the rest of the problem. You've got 2x plus 4, and you can factor out a 2. So the 2 really isn't going to matter, and you're just going to still have x plus 2. You're going to set that equal to 0. So you've got x plus 2 is equal to 0, and negative 2 is equal to x. So far, you have a vertical asymptote at x is equal to negative 2. The best way to figure out if it's truly the asymptote, what you're going to do is you're going to find the limit. The limit from the right first. So the limit of 2x plus 4 from the right, you're going to plug the negative 2 in. Negative 2 times 2 plus 4 is 0. The limit of x approaches negative 2 from the left of 2x plus 4 is still going to be equal to 0. So in the end, we know that the limit as x approaches negative 2 is going to be equal to 0. You also need to remember that at x approaches infinity, in the case of the horizontal ones, as x approaches infinity, it's going to be the line. So your horizontal asymptote on the bottom or on the top is going to be as x approaches infinity, y is never going to cross that value. So when they ask you on the AP Calculus exam what a limit of when the limit is approaching infinity, just know that you have to find the horizontal asymptote.
Let's do a harder problem.
So this function is going to be the limit as x approaches infinity of 2x cubed plus 4x over 3x to the fifth minus 4x squared minus 2. Well, first of all, we can find out the asymptotes. So, the horizontal asymptote for this one, since the degree in the bottom is greater than the degree in the top, the asymptote is going to be at y equals 0. So we'll put that down as the horizontal asymptote. Since you can't plug in infinity, since it's not an actual number, I'm going to use a number like 1,000. So as you can tell, the top is still infinity, and the bottom is still infinity. And that's not really helpful. So there's a really fun trick that we can use called the L'Hopital's rule. This rule states that you can just take the derivative of the top and the derivative of the bottom, only when the original limit is infinity over infinity or 0 over 0. So you take the derivative of the top and then the derivative of the bottom, and you find the limit as x approaches infinity still. And you can use this rule as many times until you end up with a better answer. So why don't we try it on this one? So we've got the limit as x approaches infinity. To take the derivative of the top, that's going to be 6x squared plus 4 over 15x to the fourth minus 8x. And then the 2 just goes away. Since when we would try to plug in 1,000 or another large number, it will still be infinity over infinity. Therefore, we can do L'Hopital's rule again. So in this case, that would be 12x, the 4 goes away, over 60 x cubed minus 8. I'm sorry, that would be 12x over 60 x cubed minus 8. Now, when you try to find the limit again, you still have infinity over infinity. So that means we're going to have to do L'Hopital's rule one more time. So the limit as x approaches infinity, that's just going to be 12 over 180 x squared. In that case, when you try to plug in a very large number, you are going to end up with 0. Because the bottom's going to be increasing, and the top is going to stay the same. So you're going to have a very small fraction. Therefore, the limit as x approaches infinity is going to be equal to 0. Since the limit as x approaches infinity of 12 over 180x squared is equal to 0, we know that the horizontal asymptote is also going to be equal to 0. And that's what we already got earlier in the problem. So as you can see, you can use limits as they approach infinity to figure out what the horizontal asymptote is. You can also figure out what a vertical asymptote is by trying the limit as x approaches a from the left or from the right is equal to positive or negative infinity. And at that point, you'd have a vertical asymptote.
I think I'm ready to take the calculus exam. This is going to be great.